Alright, in the last video we're talking about what functions were and how to evaluate functions, and you should be familiar with that. Another thing you should have seen is an expression that looks like this. This is known as the difference quotient for a function. And it's real important again that you understand what we're talking about when we have these letters f and x and the difference between them. Remember, f is the name of the function, x is the variable, in this case the independent variable. So when I see f of x, right, f in parentheses x, this is not f times x. This is not multiplication. So when I see f of x plus h, that's not multiplication either. You can't distribute and say that's f of x plus f of h. So real important that f of x plus h is not f of x plus f of h. Nor is it equal to f of x plus h. I've seen that before. Okay, so these are common mistakes students make. Don't make these mistakes. They are incorrect. It shows that you really don't understand what's going on. So be very clear that you understand this notation. We are going to use this expression over and over again. You have to become very familiar with this. Okay, so here's my function. Here's the rule. Input x, the output is 2x squared minus x plus 5. So again, I want to evaluate the function at x plus h and evaluate it at x. And I want to take the difference of that, and then I want to divide by h. This expression is called the difference, right? Subtracting is the difference. And then what this vertical bar means, division quotient. It's called the difference quotient. And it has important meaning for us, and we'll look at that a little bit later. So first of all, I want to just take a look at this. What is f of x plus h? Input x plus h into this function. So this says everywhere I see an x, I'm going to replace it with x plus h. So this is 2 times the quantity x plus h squared. I've replaced x with x plus h and squared it, minus replace x with x plus h, and then plus the 5. Don't forget the plus 5. So notice I do put this in parentheses, and it is imperative that you put it in parentheses. For instance, here I'm going to distribute this negative through, right? Negative x minus h. And here, we're careful, again, I think I mentioned, if I haven't mentioned this already, I will mention it over and over again. Common mistake is to say that x plus h squared is x squared plus h squared. That is incorrect. You will not get credit. You will be in trouble. You will get the wrong result. You will not progress if you make this mistake. It is not true. You cannot distribute an exponent over addition. So remember, what is this? This is x plus h times x plus h. And if I follow that out, I get x squared. The outer and inner are xh, so that's a total of 2xh plus last times last h squared. So you've got to be able to do that very regularly without much deep thought. This should be something that you are familiar with. If not, we need to work on that. You've got to work on your algebra. 90% of what we do in calculus is algebra and trigonometry and just simplifications and adding and subtracting and multiplying, just basic stuff. If you have trouble with that, you're going to have trouble with the calculus. So 2 times what? This squared, x plus h squared, is this. I'm just going to recopy this. X squared plus 2xh plus h squared, right? And then what? I distribute, right? So be careful here. This is multiplication here. I can't distribute the f over the x plus h like I was saying here. That is not true because f is not a function, is not a variable rather, and this is not multiplication. But here it is, 2 times this. So I distribute multiplication over addition and subtraction. Same thing as I said with this negative 1, really, I distribute that through. And so what do we get here? We get 2x squared, 2 times 2, 4xh, 2 times h squared, minus x minus h plus 5. Okay. Now at this point, if there were any like terms, I would combine and simplify, but there are no like terms. And so this is a big mess, right? There's a lot going on here. F of x plus h is this whole thing, okay? And that's a lot, but that's what we have to deal with in this case. And so we want to be accurate and careful with this. So now if I go back to the original expression that we're trying to evaluate and simplify, let's write it out. F of x plus h, I'm going to put that in parentheses. That's everything here that we just found. Okay, and I know that's a lot to write. Okay, but I have faith in you. I think you have enough endurance to do that. If your hand gets tired, just do some exercises with your hand. Get you a glass of iced tea or something to cool it down, relax it a little bit, and then resume. You'll be fine. Minus f of x. I'm just being funny. F of x is what? Well, it's just the original expression, right? If I plug in x, I get 2x squared minus x plus 5. And so I'm going to do that, right, like this, but as I've written it, this is wrong. This is incorrect, right? This is incorrect, and so many students will do this. You say, well, what's wrong? I'm subtracting f of x. Well, it's in parentheses, right? And what difference does that make? All the world, because this -1, right, minus this stuff, plus a -1 times this stuff, right, we're going to distribute, and what's going to happen? It's going to change the sign of all those. And if you don't do that, you're going to be in a world of hurt. You're going to be incorrect. You're going to be lost in the middle of your simplification process. So distributing, I get -2x squared plus x minus 5. Okay, so a lot going on there, and you know, again, we've evaluated it up here. This is the evaluation, but this simplifies, simplifies as much as possible. Okay, so what can we do? Well, I want you to take a look now at the top, and have a lot going on, but if you look very carefully, we have some like terms. I have a 2x squared here, and then minus 2x squared. Well, what happens? 2x squared minus 2x squared is 0, right? So I'm just crossing those out because they become 0. I can combine those to 0. I also have what? Negative x plus x, right? Well, that's 0. I have a positive 5 minus 5, that's 0. And all that goes to 0. You'd be in a world of hurt if you forgot to distribute this negative sign, because you wouldn't have that, and you would have an incorrect result. So what's left? Be very careful what's left. I've got a 4xh up top. I've got minus 2h squared. And don't forget this little negative h. It's also up there. All divided by h. So the top simplifies down quite nicely, right? You say, wow, that's great. We're simplified, right? There's more we can do. Okay, so what else can we do? There's an h down here. Someone might say, well, hey, there's an h here. Let me just divide this out, right? H divided by h is 1, so I'm good. I just cancel this 1h. That would be incorrect. 4x plus h is not the only thing being divided by h. Every term up here, and there's 3 of them, is divided by h, right? So the best way to go to simplify is to find a factor, right? Do we have a factor up top? Go back to factoring, right? There is a common factor we have here. The greatest common factor is h. Do you see that in all of these? If I factor out a h out of the top, I'm left with 4x minus 2h minus 1, right? There has to be a minus 1 here, not 0. H times negative 1 is negative h, all over h. Right? Now this h divided by h now becomes 1. Why? Because it's a factor. I can pull it all the way out. H over h times this stuff in parentheses. H over h is 1, right? You can't pull this h out here just from this one term and leave these other h's and then cancel. You can't do that, right? You have to distribute essentially, right, through each of these terms. You could do it that way as well, I guess. Okay, but then now this divided by 1 is just 4x minus 2h minus 1. Okay. There is the simplified expression. Now, there's one thing that you'll see sometimes with this expression if it's not stated from the beginning. We know from the beginning, it wasn't stated, but it's pretty clear. H, we haven't talked so much about h. Why do we have 2 variables here? Well, x can be conceivably any real number, but h, we definitely know there's a problem, right? If h is 0, we've got a problem. Division by 0 is not defined, right? Everyone, I hope, knows that. You cannot divide by 0 and get a real number. And so h cannot be 0, right? That's clear. But I'm saying that this expression where h cannot be 0 is equal to what? All the way down to this thing here, right? And look at this thing here. Could h be 0 in this thing that we said was equal to our original expression? Sure can. If h is 0, then I got 2 times 0 is 0, and I just have what? 4x minus 1. Okay? But what we're saying is these are only equal provided h is what? Not equal to 0. Because if h is 0, this is 4x minus 1, while the original expression is what? Undefined. It is not 4x equal 1, 4x minus 1. Okay. So sometimes you'll see comma, this restriction, and so that's what's going on. They're telling you that we kind of lost that information when I canceled here. I mean, still at this stage, before I did the canceling, h cannot be 0. It's clear. We don't need to write it. It's clear. H cannot be 0. But now, no, h could be 0. So I want to make sure I emphasize that these equalities, right, these equal signs only, this one right here in particular, only works provided this condition is true. By the way, I call these things equal signs. I don't know if you've ever seen these before. I hope so. They're two parallel lines, one over the other, and we put these things between things that are equal. If you are simplifying an expression, put equal signs in between them to indicate that those expressions are equal. Not arrows, okay? Not colons, commas, dashes, or any other thing, right? Equal signs, right? Between things that are equal. I don't care if you go all the way across. I got to go down because I run out of paper room, right? I can't keep writing equal, equal, equal. So I don't care how you do it, but preferably each time equal, 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 right? That's what you should do. Don't put equal signs between things that are not equal. If two things are not equal, do not put equal sign. Okay? All right. So be very clear on your work. You need to show, when I ask for support for things, this is the kind of stuff I'm going to be looking for. You need to be clear in your support, showing that you understand the process. Okay. Difference quotient is going to be very important. There'll be other types of functions we'll deal with, and we'll be looking at those. So you need to practice, practice, practice with the difference quotient. Okay. I want to finish up looking at the graph of a function, talking about that. The graph of a function is, by definition, just the set of all ordered pairs x comma f of x. Now, this is not interval notation. Now, this is, ordered pair. Thinking about like x comma y. That's what it is. Set of all ordered pairs. Input comma what? F of x is the corresponding output. So x is in the domain. It's an independent variable. We call that the input. F of x is the range value, right, or the dependent variable, or sometimes called output. So it's always that order, and the order is important. The input first, then the output. We can visualize a graph by plotting the ordered pairs on the coordinate plane, or what's known as the rectangular or Cartesian coordinate plane. And we, this is the visualization of the graph of the function. Actually, we often just call it the graph. Okay. So let's use the graph of the function g shown below to answer parts A through K. Now, a couple things about this. When we draw a graph, I've got a window here you can see in the rectangular coordinate system from x equal -6 to x equals 6, from y equal -3 to 4. Is that it? Is that the end of the story? No. This goes on forever in both directions, to the left and right and up and down. And so when I get to this point here, there is not a stoppage. So this is going to continue in this direction. And when we give you a graph, it's going to continue in that direction the same way forever. So we're not going to, say, it comes up here and this comes back down. Not going to trick you, say, ha ha, you didn't know that. So we're going to assume it's going to continue that way. Now, over here, notice it comes down, and this is what we call an open circle. We really exaggerate that open circle. We do not include that point on the graph. And in fact, there's nothing to the right anywhere here, and so the function ends there. That, again, we're not going to say, hey, it picks up over here somewhere. We're not going to say that. It stops there. Okay, going from left to right is going to stop there. Also notice we have a point here and an open circle here. We really exaggerate these. Okay. This is a function. Yeah, a function. That's really good. It's a function, right? And remember, for every function we have, for every input, which we're doing inputs on the x-axis here. This horizontal axis is the input axis, right? Remember, input is the horizontal axis variable. The y-axis or vertical axis variable is the f of x, the output. So input, output. So for every input, we can have how many outputs for a function? Do you remember? Exactly one, right? For every input, exactly one. That means any vertical line I draw can only hit the graph at most one time. And you see that's true. Notice that what happens at x equal 1, if I draw a vertical line at x equal 1, there's a hole, there's a point. And that's good because there's only one output for the input at 1. If there was a point up here, we'd have a problem, right? Because you're saying input 1, output 3, input 1, output -1, and that's a problem. That would not be a function. So when you're drawing a function, make sure any vertical line touches the graph at most one time. All right, using the graph now we can answer questions like what's g of -2? Input -2. So how do I find that? I go to the input axis, that's the x-axis, and look for -2. Where's that? That's right here, x equal -2. And then I go up or down to the graph. Where's the graph of the function? It's up here. Right, so this point right here has an x-coordinate of -2. What's the y-coordinate? +2, right? At least it looks that way. So we're estimating. If you think it's 1.99, okay. But, it looks to be about 2. And so my estimate would be g of -2 is equal to what? The output is 2. Input -2, output +2. Independent variable -2, dependent variable 2. Domain variable -2, range variable 2. Okay. What about when we input 3? So we go over across where x is 3. Here's the input. Where's the corresponding point on the graph? Which is what? 3 comma what? 1. So input 3, output 1. G of 3 is 1. What is g of 1? So we were talking about that. G of 1. We don't go up here because that's open, right? We go down here to this point, which is what? The point 1 comma -1. So input 1, output -1. We don't output 3, right? There's no value at 3. That's why that's an open circle there. What's g of -6? G of -6, well, right there is right on the x-axis, it looks like. So I would say the output is 0. Input -6, output 0. Okay. So given the input, we can find the output that way. Also, given the output, we can find the corresponding input or inputs. If the output is -2, find the value of x. So outputs are along the vertical axis, right? Where's the output equal to -2? Here. And now I move to the left or right and look for points on the graph right at height, if you will, of -2. Where are we going to be? Right here, right? And that's the point what? -4 comma -2. So input -4, output -2. So that means x is -4. If g of x equals 0, then what are all the possible values of x? Well, when is the output 0? We say, we've got one right here. When x is -6, the output is 0. That's right here. So we know -6 is certainly one of the values. So, but what are we saying? The output, again, is the vertical axis value, right? So when is the output 0? Right here, meaning the graph is on the x-axis. Where are we on the x-axis? Well, right here. We're on the x-axis right here. Where else? Right here. Of course, where we said before here, and back here. Anywhere else? No. Remember what we said. Don't be afraid, right? This is not going to go up and then back down. We're not going to fool you. It's not going to be that it's going to cross the x-axis back here somewhere, right? This continues forever in that direction. And this stops right here, so we're not going to draw anything over here. So the values of x where the output is 0 is -6, -3, 0, and 4. Now, does this violate anything about one input for every input being exactly one output? No. We have four inputs rather, going to the same output. That's okay. They each are assigned to 0. That's okay. And so when the function g of x is equal to 0, that corresponds, sometimes we talk about the x-intercepts for the graph of the function. And we can also talk about the y-intercepts for the graph of the function. Of course, the y-intercept in this case is 0, 0. Now, let's talk about the domain. What was the domain? The set of all inputs, remember? The set of all independent variables, what we can plug into the function. So that's this axis, right? Domain variables are along the horizontal axis. So what values of x do we have? Well, I mean, obviously we've got -6, because I have an output there, -5, -4, -3, -2.5, -1.9. You know, everything's here is good. Even 1, right? At 1, I got an output not there, but down here, right? At 1.1, I've got an output. It's up here, right? At 1.5, I've got an output, right? It's about what? 2.5, and so on, right? I keep going until what? 5. Do we have an output at 5? Well, if I move up or down, I never hit the graph. This is a hole. Looks like I pass right through. There's nothing there. There's no output at 5. So 5 is not in the domain of the function. What about anything greater than 5, like 5.1? 5.2, 5.3, 5.5, and so on. No. Well, that's interesting. There's a little bug going up my graph right there. Very interesting. Okay. But there's no output there at all. And in fact, for anything greater than 5, there is no output. Okay. I'm going to see if I can catch this bug in a little sticky thing here. Oh, man, made a mess. Sorry. Oh, well. That is not part of the graph there. That's a bug. Okay. So anything greater than 5, what about anything, we got -6 back here. What about anything, well, remember, it doesn't stop there. There was not a point there. It continued forever in that direction. And so if I move back here, I can get any value of any input back here, -7, -10. How about -100? Where would that be? That'd be way, way that way. Way that way, -100. Yeah, there's going to be an output. It's going to be way up there, right? But that's going to go on forever. So there is, no end this way to it. In other words, if we're talking about an interval, which is exactly what we're talking about, it's all real numbers that are what? Strictly less than 5. You remember how to write that in interval notation? All real numbers less than -5. Negative infinity, since there's no left endpoint. 5, not -5. I don't know if I said -5. 5, +5, right? Do I include +5? No, it's parentheses. Okay. What about the range? Well, the range now is the vertical axis values, right? What's the smallest range value that I have? I know at -4, the output was -2. We said so here, right? We get an output of -2. Can I get an output that's less than -2? If I draw a horizontal line rather left to right, I'm never going to hit the graph, right? We know it keeps going this way forever. It's not going to come back down, so I'll never hit it out here. And we stop right here, so there's nothing this way. So I can't get anything less than -2, but I can get -2. What's the largest value that I can get? You can go up here, we get pretty close, almost get to 3 it looks like, but there's no value there. However, don't forget, this continues forever in this direction, so I'm going to be able to hit 3, right? And 4, and 5, and 6 vertically. This thing continues to go up height-wise without bound, and so we don't have an upper bound for the range. The range can be any real number that is what? Greater than or equal to -2. Now, how do we write that in interval notation? Well, the -2 is our left endpoint in a sense, right? Think about looking at the, turn it 90 degrees, right? So negatives are here. So it's going to be left endpoint -2, right endpoint is going to go what? We have no right endpoint, so we're going to use the infinity symbol. So we've got from -2 to infinity. Do we include -2? Yes, we do, because we said right at -4 the output is equal to -2, so that's in the range. Of course, parentheses there. A couple other things we talk about, and you should be familiar with these terms, and we're going to define them with calculus. G is increasing on the interval or intervals. What do we mean by that? Well, G is increasing basically when the functional value is increasing as we go from left to right. And so graphically, it's real easy to see, I think, that between x equal -4, right, where we're at output of -2, up to x equal -2, where we're at output of 2, the functional values as we move from x equal -4 to x equal -2, the functional values are getting bigger and bigger and bigger, right, as we move from left to right. So we're increasing. We're going up as we move left to right. It's easy to see. Now here we're going down as we go from left to right. So here's the only section where we're going up as we move from left to right, okay, over an interval. And so what interval? What do we talk about? When we talk about location, where is a function doing something? Where is it this value? Where is it? We're talking about domain values. Where is the function equal to -2? Where? At x equal -4. The location is the independent variable. So when I talk about where is it increasing, I want domain values. From where? From x equal -4 to -2. All right? On that interval. Okay? And so when I come down here, where is it increasing? I'm going to go from -4 to -2, from the left endpoint to the right endpoint. Now, when I talk about intervals where we're increasing, I will always use parentheses. Okay? Some instructors will use brackets, including the endpoints, and they would be correct in this case, as long as the function exists at -4 and -2, which we do. I use parentheses just because I'm really interested in, when we're talking about increasing, we don't increase at a point. We have to be talking about an interval from here to here, as we go from here to here. That's really what we're saying, right? As we go from -4 to -2, the values of the function are getting bigger and bigger. So when we talk about increasing, we can't, give a point. So I'm going to use parentheses. If you use brackets, it would not be incorrect. Okay, it does matter parentheses or brackets here when we talk about domain and range, not so much where it's increasing, provided the function exists there. Where's g decreasing? Okay. Well, what? It's going. Remember, this goes all the way up here forever, so it's coming down forever, right? For what? Anything less than -4, right? X equal -4, it changes, right, to increasing, we said. But everything less than -4. So how do I write everything less than -4? It's minus infinity to -4. But that's not the only interval, right, where we're going down as we go from left to right. We're also going down from left to right here, and then again here. And so from here to here, we're what? X equal what? -2 to what? X equal +1. I'm going to use my union, right, from -2 to +1. And then again, what? From +1 to what? All the way down to here to 5. Okay. And it would be incorrect to split this up into two separate intervals. You can't go from -2 to 5 because we're going down, 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 and then all of a sudden we jump up, right, back up to here. And so, going down here and then going down here would be the correct way to do that. Okay. One more question. Find the values of x such that g of x, right, it's the output, range values are less than 0, are negative. What intervals is that true for this function? So what am I looking for? Again, where's the output? Output is what? The range variables. The outputs are these y values. When are the y values what? Less than 0. Well, equal to 0 means the x-axis. Less than 0 means what? Below the x-axis. When is the graph below the x-axis? Well, obviously, here we start at -6. We're below, below, right? All the way to what? -3, then we're above. So between -6 and -3, we're below the x-axis. Where else? From 0 to 1, right, in between there, and at 1. And then, right, from everything greater than 4 up to, of course, but not including 5. We do need to be careful here because it's strictly what? Less than 0, not including 0. So when I go from -6 to -3, where I know it is 0 at -6 and -3, I want to exclude those. So -6 to -3, I use parentheses around those, right? Then what? From 0, right, x equals 0 to x equal 1. Now I'm not going to include 0 because at 0 we're equal to 0, but at 1 we're equal to what? At 1 we're equal to -1, so I want to include 1. So notice this will be union from 0 parentheses, don't include, to 1 bracket, do include, right? And then the last interval we said what? 4 to 5. That's everything strictly between 4 and 5. I don't want to include 4 because it's equal to 0 at 4 and it's not defined at 5. And so this will be parentheses 4, 5, parentheses. So we've got 3 separate intervals where we're going to be less than 0. We're going to be below the x-axis. Okay. So those are the types of questions you should be able to quickly ascertain given the graph of a function. In the next video, we are going to look at another example involving the graph of a function, but this time I'm going to give you information and you're going to sketch a possible graph of the function. So we'll look at that in the next video.